Okay, good morning. Welcome to
Calculus 32.
Calculus 32. Sorry, we have a cat in the sink. This morning we're going to go through a really neat paper that I learned from a post by Dave Richardson, who announced some old articles in a couple different journals. I believe this was in the College Math Journal, if I remember right. They're going to make free for March. And I saw this paper by Susan Colley, who is a professor of math at Oberlin, at least was a professor of math at Oberlin when this paper was written in 2003. And I thought it'd make a great project for Pi Day. And so what we're going to do is we're going to start by looking at a really interesting formula for pi. And then we're going to look at one that's even better, but absolutely mysterious. Okay? Alright, so the first formula for pi we're going to look at appears at the bottom of the paper here. I'm going to show it, and then I'm going to zoom out. Okay? I should say it appears at the bottom of the first page of the paper. It is the formula that pi equals 4 times the sum from n equals 0 to infinity of negative 1 to n over 2n plus 1, which we'll say is 4 times 1 minus a third plus a fifth minus a seventh, etc. Just checking that I've zoomed out enough. Perfect. Alright, so tell me what you think about this formula.
Well, I think this makes sense. I mean,
What?
like, at least it looks like it can converge to pi.
Oh, okay. Yeah, I wouldn't say the first time seeing this formula that it necessarily makes sense. Okay, what makes you say it converges?
Well, we start at 4. We go below pi. We're going to less than 3. Then we go back above pi. Then we go below pi, but less and less each time. So we're just kind of bouncing back and forth until we come to it.
Okay, interesting. So let's focus on this series first. 1 minus a third plus a fifth minus a seventh. Do you know anything about that series particularly? Do you know, does it converge?
I believe it converges.
Okay, why?
Well, I guess just from... I guess it's kind of less than the alternating series 1 minus a half plus a third minus a fourth. You can kind of compare it to this.
Okay, well, you can't really use the comparison test for alternating series, but you're on the right track.
Well, the alternating series test, we know the terms go to 0, and the ratio between the terms eventually is going to go to 1.
Okay. All right.
So this we can say with some confidence that the series converges.
Okay, so we can look up after this video the precise alternating series convergence formula. But yeah, so we have an alternating series where the terms go to 0. So this one you remember. You remember what that converges to by any chance?
No.
This converges to ln of 2. And it appears from the paper that this series here converges to what?
Pi over 4.
This converges to pi over 4, which is an interesting surprise. So we'll take a look now, actually, at understanding why this series converges to pi over 4.